Hi everyone. Today I'm going to explain the project which I was done. It is to process gaming events in real time instead of using traditional batch processing. Player events like kills, deaths, and wins are streaming into Kafka and ksqlDB continuously process these events to maintain a live leaderboard, enrich events with player profile data, and detect suspicious bot activities using windowed aggregation. The front end receives live updates through WebSockets, so the leaderboard updates instantly without refreshing the page. So the architecture is like the system consists of five main components: event producer generates player profile and live matches, and Kafka acts as the event streaming platform that stores all the incoming events, and ksqlDB process the event streaming by joining data and calculating player scores and detecting bots using SQL queries. An Express backend provides REST APIs for pull queries and WebSockets for push queries, and the front end displays the leaderboard, player lookup, and bot detection alerts. So the project includes live leaderboards with continuous updated scores and player profile enrichment using stream tables and real-time bot detection and player score lookup through REST APIs and live leaderboard update using WebSockets. And entire project is fully containerized using Docker Compose. As I have already started the Docker, so the using the Docker Compose app -d, this command starts Zookeeper, Kafka, ksqlDB server, and ksql command line using Docker Compose. And I have just run the load profile. This generates sample player profiles and publish them into the player profiles Kafka topic. As you can see, they were loaded around 300 players into the player's profile. So let's create the ksqlDB streams and tables. Executes all the ksql scripts that this executes the ksqlDB scripts and creates the streams, tables, joins, leaderboard, materialized views, and bot detection queries. And let's run the simulate. This continuously generates random gaming events such as kills, deaths, assets, wins, and loss, and streams them into Kafka. As we can see, there are around 200 events sent so far. So let's open a new terminal and start. Let's start the backend. So this starts the Express server, which exposes the REST APIs and WebSockets endpoint for the front end. The dashboard is live, so let's open it. Here we can see the live leaderboard updates automatically so as new events are processed. Let's run the demonstrate like bot detection message layer 7. This script, you can see the updates were done. The script has a large number of kill events for a single player. Once the threshold is crossed, the ksqlDB window aggregate detects suspicious activities and the dashboard immediately displays a bot alert. And we can even get uh, the endpoint performance, a pull query on the leaderboard materialized view and return the player current score to the API. You can see the endpoints performs a pull request on the leaderboard, materialized views, and returns the player current score. And this is completely about the project, which is an end-to-end real-time event streaming architecture using Kafka and ksqlDB. It shows how streaming SQL can be used to build live dashboards and enrich streaming data, detects anonymous, and push real-time updates to user with low latency, all using a scalable containerized architecture. Thank you for watching.